Hello, grade 12s. Hello. This is my first time going live on YouTube, so I believe everything will work out. I want us to look at the questions which I believe they are the most probable questions for tomorrow, the questions that you can meet as you write your mathematics paper 1 June exam. So the first thing that I'm going to be exploring is the topic of functions. Some of you texted me and say, we want sequence and series. We want question one. Question one, I won't do it, but sequence and series, I will share some ideas of sequence and series. So my focus will be on functions and calculus because I know that these are the key topic for paper one. These are the topic you must know if you want to excel mathematically in paper one. Functions and calculus are the key questions. So today we are going to be exploring the examiner's taste. Which questions do they bring more often? What is it that we can expect tomorrow? Obviously, hyperbola function is there. I don't see the maths paper one questions without the functions. So I expect hyperbola functions, I expect the quadratic function, I expect the exponential function. So we expect some calculus stuff. So obviously it will be interesting tomorrow. We are wondering what is it that the examiner will bring, but it's going to be very, very, very interesting. Now, the question that I want you to treat accurately as a strong preparation for your tomorrow's exam is Mathematics Paper 1, November 2024. It has got great questions, especially concerning functions. I'm not just picking it because they just wrote it last year, it was a November exam. No, the question itself has got great stuff, interesting questions of functions, and this is what you must know. So let us look at question 5 of November 2024, paper 1, hyperbola function. So if you look at the question 5 of November 2024, paper 1, we are going to consider this question as the interpretation of a function. So let me write this one down. Okay, I wish someone can tell me that, say, oh, you see, oh, okay. Just tell me what is going, guys. How is it going? Just tell me if I have to zoom. Last time they said I must zoom the screen. So let me consider that actually. Let me not forget. Last time they told me to zoom. Okay, just tell me your difficulties. Just text me on the YouTube app there. I know you can be able to interact with me. Just tell me and tell me how is it going. I'm hoping that everything is going so well. Last time some were texting me and saying, sir, can you please zoom the screen? Some were saying, sir, we cannot hear you. So tell me if you are, yes, tell me how is it going? Are you able to hear me? You're welcome is I am tap 00. Okay, you're welcome. You're welcome, guys. So let's look at this question. Just tell me how is it going. Question 5, November 2024. Don't make a mistake. This one you must understand. Hyperbola function. So the sketched below is the graph of f of x. So they are saying what you see here on the diagram, the sketch that you see is the graph of f of x, which has got the domain. They wrote a domain. Normally, they don't write a domain this way most of the time when we are dealing with a hyperbola function. I'll give you a different way of writing the domain. They can also say x is the element of a real number, but x should not be 1. The same information that they've written here as a domain, They can write it that way. They can say x can be any number. X can be any real number, but x shall not be 1. So they are giving us the domain of a hyperbola function. And please, 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 grade 12. From the domain of the hyperbola function, you can know the x asymptote. There is a huge relationship between the x asymptote and also the domain of a hyperbola function. Let's say you have something like this. I'm just giving you my function here. Let's say you have got f of x equals to 2 over x minus 3 plus 4. This is the function that I'm giving you. And I ask you to find the x asymptote of this function f of x. What are you going to do? Remember that when you are looking for the x asymptote, which we also call the vertical asymptote, you have to equate your denominator to 0. Therefore, x equals to 3. This is the x asymptote of this function f of x. We also call it the vertical asymptote. The x asymptote is a vertical asymptote. Now, from this x asymptote, I can give you the domain now. The domain of this function f of x. And watch out, they might ask you to determine the domain of a hyperbola function. So you need to know how to determine the domain of a hyperbola function. From the x asymptote, I can know the domain. How so? Okay, the domain of this f of x, I will say x is the element of real numbers, but x shall not be 3. This is the domain. That is why I'm saying there is a huge relationship between the domain of a hyperbola function and the x asymptote. From the domain, we are able to know the x asymptote. Okay, so if I give you a domain in this manner, let me say I tell you that there is a hyperbola function, and this hyperbola function, it has a domain of x is the element of real number, but x shall not be 1. What I'm simply saying, from the domain, you can tell the x asymptote. The x asymptote, what is the x asymptote? It's 1. Your x asymptote in this case, it's 1. You just know the x asymptote from the domain. So there is a big relationship between the domain and the x asymptote. So let's go back to this question 5 of November 2024. We see that they gave us the domain there, which says x is the element of real number, x is not 1. So from this domain, we know the x asymptote. Let me write that. We know the x asymptote. And what is the x asymptote? My x asymptote is x equals to 1. Oh, wow. They even actually showed it on the graph. Another way of identifying the x asymptote is by this dotted vertical line. So this examiner was very kind because he's showing that the x asymptote is 1. You could have just read that from this guy, from the domain. From the domain, you can know that the x asymptote is 1. But the examiner showed it with a vertical line. So we do know that the x asymptote, actually, it is 1. Remember, this x asymptote is a vertical line. Okay. Now, they are also telling us that the graph of f cuts the y-axis at 0 and 1. So let us look at the point that they are talking about. The graph of f cuts the y-axis at 0 and 1. This is the point they are talking about. They are referring to this point here, where the graph of f cuts the y-axis. Remember, this is the y-intercept. This is the y-intercept. And what is the coordinate of this point where the graph of f cuts the y-axis? they are saying it's 0 and 1. Now pay attention, pay attention. A point on the graph can be used to substitute x and y. This is another mathematical skill which is very important. And I don't see you writing your maths paper 1 from the start to the finish and you don't use this idea. If a point is lying on the graph of f, in this case, a point which lies on the graph of f is 0 and 1. This point can be used to substitute x and y in the equation. Let me explain what I'm talking about. If you look at the equation of f, the function f, what is the equation of f? F of x is equals to a over x plus p plus q. What I'm saying is that because the point 0 and 1, it is seated on the graph of f, you have a right to say 0 is x, 1 is y. You go and substitute on this equation. You say my f of x is 1, my x is 0. This is another skill that you must possess as you prepare for tomorrow's test. Just know that just because the point is lying on the graph of f, we can use it as a substitution. We can go to the equation f of x equals to a over x plus p plus q and say our x is 0, our y is 1. This idea of substituting x and y, f of x represent y, by any point on the graph works most of the time in maths, especially when we are dealing with functions. I said to you guys, you must tell me how is it going. So let me check if there is anyone who texted. Okay, no one has texted. Okay, let's just continue and see what's happening here. Let's continue. Don't worry, I will attempt questions. I know you guys, you want those questions. Okay, we are also given a line of symmetry of f, which is given by g of x equals to x minus 3. I wonder if you guys can hear me. Last time my speaker was muted, but no, this time around it's not muted. This time around it's not muted. I just wanted to make sure of that. Okay. Another thing that they gave us is a line of symmetry of f. Remember, a hyperbola function has what we call a line of symmetry, or what we call the axis of symmetry. The hyperbola function has got two axes of symmetry. One of the line of symmetry has a positive gradient where m is greater than 0. Another line of symmetry has got a negative gradient where m is less than 0. Okay, a line of symmetry. So a hyperbola function has got two lines of symmetry, one with a positive gradient, the other with a negative gradient. So they gave us this line of symmetry here. G of x is equals to x minus 3. What I'm going to do now, is very, very, very important, guys. I need you now to pay attention. You have a line of symmetry. This line of symmetry always pass at the intersection of the asymptote. Okay, so if one of my asymptote is a vertical asymptote, this one, and one of the other asymptote is this one, these two lines, the vertical line and the horizontal line, meet at this point. This is where the axis of symmetry will pass through. the axis of symmetry pass at the intersection of the asymptote, where the vertical asymptote and the horizontal asymptote meet. That's where the axis of symmetry will pass through. So now I want you to pay attention. We have the vertical asymptote. We know that the asymptote of this vertical line is 1. We want to know the horizontal asymptote. What is the horizontal asymptote? Okay, watch out. I'm going to say the point where the axis of symmetry pass is made up of 1. I know that this vertical line is the line of x equals to 1. So the point is 1 and something. I don't know the y coordinate at this point. And if I can know the y coordinate at this point, I will know the y asymptote. So I'm going to say, okay, g of x equals to x minus 3. This line of symmetry pass at a point where x is 1. So I'm going to substitute x with 1 to find the y value at this point. So the coordinate of this point, actually now I know it's 1 and negative 2. I calculated the y coordinate of this point using the axis of symmetry, because the axis of symmetry is passing at this point where x is 1. So you go to the axis of symmetry, you substitute x with 1, and then you try to calculate the y value. Y is negative 2. So now I can give you the coordinates of this point actually and say the coordinates of a point where the axis of symmetry is actually 1 and negative 2, which means that the horizontal asymptote is y equals to negative 2. So I have both my asymptote. I have the x asymptote, which is 1. I have the y of asymptote, which is negative 2. Okay. Now I think we can even attempt the first question. Write down the value of p. This should be interesting. Write down the value of p. So what we're going to do, we are going to look at p on our equation. Where is p? Or p is this one. It's p, it is a variable on f of x. Look, f of x is equals to a over x plus p plus q. So they are saying write down the value of p. Most of the time when we say write down, you don't have to make calculations. Most of the time you don't make calculation. You just have to see it from the diagram, because we are saying write it down. We are saying you can find p without calculations. Write down the value of p. So they are saying it's easy to find p. And then guys, where there is p actually, watch out. See, the denominator, it's x plus p. Okay, where there is p, normally it's where the x asymptote sit. So p has got something to do with the x asymptote in this case, because we are having x plus p. And then I'm saying where there is p, it's normally where the x asymptote is. So what is my value of p? I'm going to say, okay, the value of p is negative 1. Why? Why, sir? Why do you say the value of p is negative 1? Okay, listen attentively. As long as you have got a positive sign between x and p, as long as you have got a positive sign, the value of p is the same as the x asymptote. They only differ with a sign. In this case, it means that if the x asymptote is 1, the value of p is going to be negative 1. I'm saying this again. As long as you are having plus p, it means that the value of P is the x asymptote but with a different sign. If the x asymptote is 1, P is -1. But if they had written something like this, if they had set x minus P, not plus P, it means that P is exactly the x asymptote. If Kamofa Servia x minus P, P is exactly the x asymptote. But if it's x plus P, P is the x asymptote but with a different sign. So now we found P is -1. That is why they said write down. It is easy to identify the value of P without even making calculations. Remember this, when we say write down, we are saying the answer is just nearby. You don't have to make a lot of calculations. So my P is -1. Now determine the equation of the horizontal asymptote of F. Determine the equation of the horizontal asymptote. I already actually answered this one. I said y equals to -2. How did I find this y equals to -2? To find the horizontal asymptote, I used two things. I used the line of symmetry, which is y equals to, or let me just say g of x equals to x minus 3. And I know that this line of symmetry pass at the intersection of the asymptote, where the x asymptote and the y asymptote meet. Now, because I have the x asymptote, I can find the y asymptote by simply saying y equals to, substitute x with the x asymptote, 1 minus 3. Y equals to -2. So you found the horizontal asymptote, y equals to -2. Please practice this question of November 2024. Now they say calculate the value of A. Let's go and look at the A which they are talking about. A that they are looking for, it is A on the function f of x equals to A over x plus P plus Q. They are looking for this guy here. They are looking for this guy here. They are looking for A, this guy. I think it should be easy to find A now. I won't be surprised if they bring something like this tomorrow. That will not surprise me. If they bring a hyperbola function this way, I won't be surprised. Okay. I want to find A. What am I going to do to find A? I'm going to do this. I'm going to do this. I'm going to say, okay, f of x, what I'm trying to pick a pen, f of x equals to A over x plus, remember we found P, we said P is -1. So it's going to be x plus -1. So it's going to be x minus 1. Plus, we also found Q. Remember this Q, it's actually the y asymptote. And we found the y asymptote to be -2. We had y equals to -2. So my Q is -2. The Q guy represents the y asymptote. Now, I can find A here so easy. How? By substituting, if we look at this equation, if I substitute my x and my y, by any point from the graph, I should be able to find the value of A. Which point is on the graph? This point of 0 and 1. They say this point is a point on F. So what you do, you say my f of x, my y, it's 1. A over my x is 0. Now it's 1 equals to A divided by -1 is -A, -2. Then You take negative 2 to this side. 1 plus 2 equals to negative a. Therefore, a equals to negative 3. So you found the value of a, which is negative 3. That was 5.3. So you should be able to answer 5.1, 5.2, 5.3 without lot of challenges. Okay, remember my goal is to prepare you, and I want you guys to see how the questions link. I'm going to now look at the question of November 2024, because there is, I mean, not November 2024, June 2024, because there is something interesting there also on June 2024. Okay. Oh, Tibo, thanks, Tibo, thanks, Tibo. Okay, Shiman Patlele says, what about the domain? How do I see that M is negative or positive? I don't understand. Okay, okay. What about the domain? I will talk about the domain. How do I see that M is negative or positive? I don't understand. Okay, let me answer this one of Provia, because it's this one it's a must know Provia. So let me remain on November 2024. Okay, November 2024. It means I have now to talk about the axis of symmetry. The axis of symmetry. Hyperbola function has got two axes of symmetry. I said one of the axes of symmetry has a positive gradient, and the other axis of symmetry has got a negative gradient. Okay, I think I will explain this one better when, let me say we have got f of x, which is equals to a. We found, how much was a actual? I think it was negative 3. And then x minus 1, q was minus 2. Let's say we give you something like this, and we say to you, determine the axis of symmetry. So we will tell you actually which axis of symmetry we are looking for. We can say to you, find the axis of symmetry which has a positive gradient, meaning that m is greater than 0. Or we can say to you, find the axis of symmetry whereby m is less than 0. So these are the two axes of symmetry. So how do we find this axis of symmetry? I said I'm showing you a different method now, and hopefully I'm hoping I won't confuse you. Another way of finding the axis of symmetry, you just pick y, you say equals to, you pick your denominator, you leave only the number on top. You just pick these guys. So from here now you say y equals to, you pick your x minus 1, you pick your minus 2, y equals to x minus 3. This is your axis of symmetry with a positive gradient. It was easy. You just focus on the denominator and the number, the number at the end. Now, this one is 1 for y equals to x minus 3. This is the axis of symmetry with a positive gradient. If we say to you, the axis of symmetry of a negative gradient, now you can do this. You still focus on the same thing. You say y equals to, the difference is very small. You say y equals to, you now pick x minus 1, but this x minus 1, you must now multiply it with negative, because you are looking for the axis of symmetry with a negative gradient. Now y is equals to minus x plus 1 minus 2. Y equals to minus x. 1 minus 2, it's minus 1. So this is the axis of symmetry with a negative gradient. Okay. Now I wish that you are here. You are here. I know what I want to say now. It's very important. They might trick you in the exam. They might trick you in the exam. They might say to you, find the axis of symmetry which intersect with f of x. Okay, let us go to this graph of f of x. With f of x, do not forget it's my hyperbola graph. So we can say to you, find the axis of symmetry, the line of symmetry, which intersect with the graph of f of x. Do not forget that the line of symmetry pass at the intersection of the asymptote. The line of symmetry pass at this point. So if we say to you, find the axis of symmetry which intersect the graph, watch out, look, this line of symmetry that pass at the intersection, this line does not intersect the graph. And this is the line where m is greater than 0. How do we know that the gradient of this line is positive? When you are starting the straight line, observe it from the left. Observe it from the left side. We want to reakai. So if we are looking at it from the left, it's going up. So it means the gradient of this line, it is positive. So this is the axis of symmetry which has got a positive gradient. And look at this line, it's not intersecting the graph. So another axis of symmetry will do intersect the graph. So they can say to you, find the axis of symmetry which will intersect. Another one will be coming in this direction. This one does intersect the graph. So this is the line of symmetry that they will be looking for. If they say determine the axis of symmetry that intersect your function f of x, and this line of symmetry has the gradient of less than 0. So they will be looking for this one. But they might confuse you. They say find the axis of symmetry that intersect the graph. When I was which axis of symmetry? So you need to watch out. So, okay. But sometimes, remember, our hyperbola graph can be like this. Sometimes our hyperbola graph can be in the first and in the third. So whenever the hyperbola graph is in the first and in the first, it means this line, this one will do intersect. This one will do intersect. The one that will not intersect now is this one. Both this line, they pass at the intersection of the asymptote. So you need to be careful. They can say find the axis of symmetry that intersect the graph, or maybe they say that does not intersect the graph. The question that I want now, that I want us to go for, please make sure that you do this question June 2022. So you must do November 2024. It has got great stuff that might come tomorrow. And you also look at June 2022. So let us look at the question of Maths Paper 1, June 2022. Also, June 2022 is the interpretation of a function. How do we know that is interpretation of a function? Because they might say find A, find P, find Q. Let me zoom. Okay. Okay, so this is June 2022. It has got interesting question as well that they might bring. So you need to treat the question of June 2022. Okay. How how do we find this question of June 2022? How do we treat this one of June 2022? They are saying, I just want to answer 5.1 for June 2022. And I will be a bit faster. I want us to get this 6 mark. Okay, the following information of G is given. They are saying X is the element of real number whereby X is not negative 2. So what can we get from the domain of a function? Remember, I said from the domain of a function, you can get the X asymptote. So they say X is the element of a real number. X is not negative 2. So what is the domain of G of X? I mean, what is the X asymptote? The equation of the X asymptote, according to the information, is negative 2. From the domain of a function, you can get the X asymptote. So the X asymptote is negative 2. Now, 5.1 says show that the equation of G is given by minus 3 over X plus 2 plus 1. So this is what you do. You are going to say G of X equals to A over, let's calculate this P. Let's find the value of P. I told you that as long as the sign between X and P is positive, it means that P is the X asymptote but with a different sign. So what is the X asymptote? The X asymptote is negative 2. It means that P is 2. So we're going to say X plus 2. We found P so easy. Plus Q. So what we have to find now from here is the value of A and Q. So you are going to use that idea that I talked about. Now look, this point 1 and 0 is a point on the graph of G. So you have a right to put your G of X 0. This Y, you can put it 0. You can put your X 1. Which means 0 equals to A over 3 plus Q. Let us multiply throughout this equation by 3. Let's multiply everything by 3. 0 times 3, it's 0. A over 3 times 3, it's A. Q times 3 is 3Q. So this is my equation 1. So now I can do the same thing to find equation number 2. So I will do it here actually. I will say G of X. My G of X now is negative 1 over 2. My Y is negative 1 over 2. My X is 0. I'm using the point 0 and negative 1 over 2 because also it's on the graph. So 0 plus 2 plus Q. So minus 1 over 2 equals to A over 2 plus Q. Multiply everything by 2. Minus 1 equals to A plus 2Q. This is going to be my equation 2. So let me write these equations close to each other. I'm having equation 1. I'm having equation 1, which is oh, I raised it by mistake. But here I have equation 2, which is minus 1 equals to A plus 2Q. Remember, this is my equation. My equation 1 is, it was 0 equals to A plus 3Q. which is equation 1. Now we solve these two simultaneously. You can take equation 2, subtract equation 1, or you can take equation 1 and subtract equation 2. So let me take this one underneath, subtract the one on top. Let me say 1 minus 2. Equation 1 minus equation 2. So 0 minus minus 1, it's 1. A minus A, it's 0. 3Q minus 2Q, it's Q. So 1 equals to Q, which is this number here. It's your Q. You see that 1 equals to Q. So you have P, we found P being 2, we found Q being 1, so we have to find A. We have to find A. When you are looking for A, go to any of these two equations. You can go to equation 1 or you can go to equation 2. Let's just go to any of the two equations. Let's go to equation 2. From 2, we have minus 1 equals to A plus 2Q. So 2 into 1. If we take this 2 this side, it's going to be minus 1 minus 2, which is minus 3, equals to A. So the value of A is minus 3, which is this guy. So we found A being minus 3, Q 1, P 2. So go and practice June 2022. I'm going to stop my live meeting. Let me check before I leave if there is any question. Okay, no question. Let me stop my meeting. Thank you for being here.